Now for the fun one. Here we go. We get to add and subtract these things. Isn't that awesome? So let's go back and look at some of the old adding, subtracting that you used to do back in 5th grade. So if you're looking at this first one, we have a denominator of 5 and a denominator of 6. Remember, when you add or subtract, these denominators have to be the same. So now you're looking at what do both of these go into. Remember, to find a common denominator, we have to multiply by the same thing. We have to multiply to get the common denominator so that they are the same thing. So if we look at multiples of 5, we've got 5, 10, 15, 20, 25, 30, 35. And if we've got the multiples of 6, we've got 6, 12, 18, 24, 30, 36. Now they both go into 30, so that's what we want to do. We want to turn them both into 30. So we take and we multiply 5 by 6, because 5 times 6 gives me 30. Now notice, that is the same as the other denominators. So if these two denominators don't have anything in common, then we just multiply by the other one. So this one has a 5, we need a 6, because if we have both of them, they make 30. So then I also, whatever I do to the bottom, I have to do to the top. And then on the other one, we multiply by 5 so that we get 30. What I do to the bottom, I have to do to the top. And now that I have 12 over 30 plus 25 over 30, now I can say, you know what, because the denominators are the same, I can just go ahead and add the top. So I've got 12 plus 25 is 37 over 30. Okay, now every once in a while you're going to get a fraction where you're not going to take 4 times 6 and 6 times 4. I mean, you could, but you're actually going to have some reducing to do later. Instead, what you want to do is you want to say, well, if I looked at the breakup of 4, I've got 2 times 2. And if I look at the breakup of 6, I've got 2 times 3. So you'll notice they both have a 2 in them. So really, your common denominator is going to be all of this, so 2 times 2. And then since this one already has a 2, you only need a 3 more. So your common denominator is really going to be 12. Now maybe you could tell me that at the beginning. Maybe you could look back here and say, you know what, 4 and 6 both go into 12. But ultimately it comes down to what factors do these have in common, and then what do they have extra. You know, you can see this in a Venn diagram also. If this is 4 and this is 6, they both have a 2 in common. The 4 has an extra 2 and the 6 has an extra 3. And so then what happens is everything in the whole Venn diagram is your common denominator. They both share a 2, you need an extra 2 and an extra 3. And so then as I do this, I say, well, the 4 has a 2 and a 2, so it needs a 3, so I multiply by 3 top and bottom, which you would have said anyway because it was 3 times 4 gives you 12. And then the 6 needs an extra 2, so we multiply top and bottom by 2, which you would have said anyway because 6 times 2 gives you 12. And now we have 5 over 12 plus 2 over 12 gives me 7 over 12. Notice the 12 stayed the same. I didn't put that together and make it bigger. All right, so now we go to our rational examples, rational expression examples. Now you could be lucky enough that they are already the same denominator, so then all you have to do is add the tops. 4 plus 5 is 9, so it'd be 9 over 3x, and then you have to always look and see if you can reduce. 3 goes into 3 once, 3 goes into 9 3 times, so you get 3 over x. Okay, on the next example, they already have common denominator. Now look at this, 2 minus 4. 4 doesn't have an x on it like the 2 does, so you can't actually subtract them. So what you have to do is just write what you have. You have 2x minus 4 over x plus 3, and that would be your answer. Okay, if you don't have a common denominator, now you actually have to do some work. So remember, you have to multiply to get a common denominator. So even though they both have an x, I really don't look at this as just being an x. This is all one thing, x plus 2. And this is all one thing, x minus 3. And so I'm going to put bubbles around them. And basically it's just like that 5 and 6 one. X plus 2 needs an x minus 3. So I multiply by x minus 3 on the top and the bottom. And then x minus 3 needs an x plus 2, and so I multiply on the top and the bottom by x plus 2. Alright, and now it's time to do the math. See, the bottom is x plus 2, x minus 3. Same thing on the other one, x plus 2, x minus 3. So we can just write x plus 2, x minus 3 on the bottom, and it's our common denominator. I don't make it bigger or anything like that. And then on top I have to do my math. 5 times x is 5x. 5 times 3 would be minus 15. On the other one, 7 times x is 7x, and 7 times 2 is 14. So now we have some simplification to do. So we have 5x plus 7x is 12x, and negative 15 plus 14 would be negative 1 over x plus 2, x minus 3. And that's your answer. Okay, there's no canceling there that we can do. So we are done with that problem. Okay, of course it gets more complicated. Why wouldn't it? So here, it's just like the 4 and the 6 now. Remember with the 4 and the 6, we broke down the 4 to 2 times 2 and the 6 to 2 times 3 because we wanted to see what they had in common. We're going to do the same thing here. I'm going to break both of these bottoms up so that I can see what they have in common and what they need. So the x squared plus 4x plus 4, that's going to be a double bubble. So we'll use a box to help us out there. Got x and x, 2 and 2. So then we get 2x and 2x. So now we see that we can factor the bottom into x plus 2 and x plus 2. Now going on the other one, that x squared minus 4, that's also a double bubble, but it's one of those special ones because it's a squared minus a squared, so we'll have a plus 2 and a minus 2. So then those will cancel out just like we want them to. So we have on the bottom here x plus 2 and x minus 2. So just like the 4 and the 6, they have something in common. They both have an x plus 2. The thing is, this one has an extra x plus 2 and this one has an extra x minus 2. So if we were to look at the Venn diagram on this, they both have an x plus 2, this one has an extra x plus 2, this one has an extra x minus 2. So your common denominator is you're going to have two x plus 2's and then an x minus 2. So that's what you're looking at while you're finding your common denominator here. So let's see here. This first one needs an x minus 2. So I'll multiply top and bottom by x minus 2. The second one needs another x plus 2, so I'll multiply top and bottom by x plus 2. So now I have to go through and do the math on this. So on the bottom, that'll be the easy one. It'll be x plus 2 times x plus 2 times x minus 2. On top is where I have a little bit of work to do. First off, for these ones here, I need to take this times this. This should have a parentheses around it. So I'm going to use a box to do that. So we have x minus 2, x plus 1, x squared minus 2x, x, and minus 2. So on top we'll have x squared minus 1x minus 2. And then over here, I need to take that 2 and multiply it through. But here's something tricky. This minus sign, imagine this minus sign is attached to the 2. So when I take the 2 and multiply it through, I'm going to attach the minus with it. So it'll be a minus 2x and a minus 4. So now, as I try to solve this, I need to combine my like terms on the top. So I get an x squared minus 3x minus 6. And then I still have x plus 2, and x minus 2. And that would be my answer on that one. Okay, sometimes the factoring that you can do isn't going to be a double bubble, but just that you can take something out. So on this one, on the second fraction here, I can take out a 3x squared. And if I take out a 3x squared, I get a 2x plus 1. Okay, now, as I'm comparing this fraction denominator with this one, I see that they both have a 3. But then I'm a little bit confused because I have an x cubed and this one's an x squared. So what I'm going to do is I'm going to break this down a little bit. You don't have to do this, but it helps for some people. So I'm going to break it down, and I'm going to take that x cubed and I'm going to make it an x squared and an x to the first. That way, when I'm looking for something that they have in common, they both have 3x squared, and I can see that easily, and I also can see what's left. So if we look at this, this first one has a 3x squared in the x, but it's missing the 2x plus 1. So I need to multiply by 2x plus 1, top and bottom. The second one has the 3x squared and the 2x plus 1, but it's missing that extra x. So I'm going to multiply by that, top and bottom. So now on the bottom, is going to be all of this put together. I'm going to put these back together again just because it's simplified. So I have 3x cubed times 2x plus 1. Now on top, I need to take that 4 and multiply it through, so I get 8x plus 4 plus, and then my x's can go together, x squared. And the only other thing you could do is just rewrite it so that it's in the proper format of the biggest exponent down to the constant. But otherwise, this is your answer. Sometimes people wonder, should I multiply the bottom together? Should I multiply this out? You can, you don't have to. A lot of times it just depends too on what you see in the book. So I know these are getting to be long videos. I'm going to try and hurry up. Let's see, how many more do I have here? You know what? I think I'm going to be done just because you know, these are things that we can go together in class. All right. Adios.